Alright, hey guys, welcome to another tutorial. We're going back into Breakout, but we're going to set up the ball this time, because now we have our playable camera, one-player camera, that we can move back and forth like this. So, all that is pretty good. So now we need to actually have a ball on this guy. So, let's go ahead and start that out. So we're going to start out from our blank blueprint here. Just go right-click, go to blueprint. It's just going to be an actor blueprint. We'll call this Breakout underscore ball. Or not. Okay. I think I already have something named that. Let me rename this. Let's see. Just name it Breakout. Let me see. Breakout bouncing ball. So let's open this guy up. He's a very blank, I guess, blueprint for the components. So we're gonna have a few different kind of components. Honestly, the first thing is gonna be our root. We're gonna make this the collision. So we're gonna type in, I believe it's sphere. Yeah, we're gonna type in sphere. We're gonna call this ball collision. And then tooltip, I'll just write. I'll type in main collision for ball. And we're gonna scroll down here. And we're going to set some variables up for it. We're going to change the shape of the sphere in a moment. We're going to wait till we actually have a mesh in there. But all we're really going to do, we're going to check a couple of things. We want to make sure the simulation generates hits event. We want to make sure that it overlaps events is good too. But we're going to set this all to, we're going to set this, we're going to do, I believe we're going to do block all. And that's it for the ball collision. So right now what we have set up, we have it's generating hit events, and we just have a block all. We haven't changed the sphere radius just yet, but we're going to do that next after we add a static mesh. So let's just type in static mesh up in the add component. I'm going to call this breakout ball. I'm going to give a tooltip mesh for the ball. So now, down here under where it says static mesh, that's where we're going to go into our content browser. I have one of the meshes here. I just grabbed the sphere, the typical sphere from the game folder, but I just copied it, made my own ball, and made it SM ball. So we're going to add that in. And as you can see, it's nowhere near the size of the sphere collision or anything like that. So, we're going to change the shape of this sphere, or the ball, to 0.25 in all axis. So that's what it looks like in the game. That works as a good size. Then we're just going to move this up in the center here, try to center it up. And then we're going to go back to the ball collision. Now we're going to start changing the sphere radius. I believe about 14 is a good shape for it. And then we'll take the ball, we'll move in position. Maybe even do something like 13. Yeah, that looks good. So now we have the breakout ball, the actual mesh, and we have the breakout ball's collision. But now we're going to do the actual mesh's collision. We don't want it to generate any overlapping events, and we don't want this to actually have any collision, just because we have that sphere for it. So that's all we need so far, but there's one more component we're going to add, and that's just so we can get the ball moving. So let's type in projectile movement in the add component bar at the top. We're going to name this ball movement. I'm going to have a control tip, tooltip for controls, movement parameters of ball. And we're going to change a couple of these default settings, not many of them. First, obviously, we don't want this ball to have any gravity, or else it'll just fall straight down. So we're going to set that to 0. And then what we're going to do, we're going to go down a little bit more where it says projectile bounces. Should bounce, yes, and then we're going to set bounciness to 1, just so no velocity is lost, just so it can continually bounce. And then we're going to give it a velocity. We're going to give it a velocity of 200 in the X, and then negative 150 in the Z, so when it starts, it moves to the bottom right. So that's positive in the X and negative in the Z. So that's actually all the components we need so far for this ball. We're not going to do much more with the actual components, but the next part, we're actually going to set up a lot of different functionalities for the ball. We're going to get this ball to bounce around, take collision from the player, the paddle, how to change color, set up a material. We're going to do all of that. So speaking of that, let's go ahead and make the material. I have one made already. I'll show you what it is. So it's basically a very simple material. I'll break it down. What we do, we right click, we do vector parameter, and it gives us a vector parameter. I already made mine here. I named it ball color, and for ball color, I set its color to white, just 1, 1, 1, 1, and the red, green, blue, and alpha channels. And then I created this emissive intensity, and that's actually a scalar parameter. So if you just right click and type in scalar parameter, you can name it whatever you want. And I set that value to 1. It's just a scalar parameter. It's a float vector. And what I do, I put the all color channel from ball color into base color, but then I multiply that color with the emissive intensity and plug that into the emissive color, just so we can control how bright the ball is. So if you want it to be super bright, or even really bright, or not even bright at all. So we're going to leave it at 1. The default setting is fine. So now that we actually have set those the vector parameter, we can actually set it up so that the ball can change color upon bouncing. I have a tutorial that goes over that too, but I'm going to do it again here for this video. So what we need to do first is go into our construction script. This is where you start any kind of like base attributes of your actor, your blueprint. So obviously we want to, at the very beginning when it's first constructed, we want to create a reference to that dynamic material. So what we're going to need to do is we're going to right click, type in create dynamic material instance. Going to throw that guy into the construction script. And I believe it is, we got to get the breakout ball, plug that in, or not. Let's try this. We'll take the breakout ball, drag out of it, and then we'll type in dynamic material instance. There we go. Now we plug that one in, and then what we're going to do is we're going to set this as a variable. So now we have a variable that controls this dynamic material instance. We're going to name this variable ball color. And that's all we need to set up in the construction script to get this going. But we'll reference this later. We're not going to do anything just yet with this. We're actually going to set up more parameters for the ball in the actual event graph. The first thing we're going to do, because in Breakout, when you die or you start the game, the ball has an initial position, and when the ball lands out of play, it resets that position. So we're going to set that kind of functionality up as well. So to start that, we're going to go start with an event begin play, and then what we're going to do, we're going to get the breakout ball. Type in, I believe it's called get location, get world location, and then we're basically going to promote this variable, and we're going to set it at the beginning of play. And we're going to name this variable. We're going to call this ball start position. Put a tooltip here for it, just saying the initial position of the ball. We're going to compile that. So now, as soon as the game starts, we get the player's location, the ball I should say. We get the ball location, and then we store that location as a variable, and we name that basically ball start position. And we're going to be able to reference that later. But now we're going to start getting into the nitty-gritty of it all. Basically what we're going to do is we're going to set up collisions for the ball, just so it doesn't continuously just fly off screen. Because right now if we put the ball into the scene, and then we play, it can hit the player, but it's just flying off screen. So we're going to set up those bounds basically. So that's going to be starting with a tick event. So let's just type in tick. And basically tick is every single frame calculated by the machine you're working on. So what we're going to do with the tick, every tick we basically want to update and check to see if the ball has left the bounds of the play space that we want. So what we're going to do, we're going to get a sequence. We're going to plug that in. And this sequence is going to have in total 4 output pins. So we're going to add pin 2 times there. So now we have 4 outputs here. And basically what this is going to control, each one of these. So the first one is going to check the positive X bound. The second one's going to check the negative left X bound. The third one's going to check the positive Z bound. And then the third is going to check the negative Z bound. So that's how we're going to have those all set up. So let's go ahead. We're going to basically create a couple things here. Because overall, the collision bounds checks that we're going to make, we're going to create functions for those. But we'll make them from scratch first. So what we need to do is make a custom event. And the first thing we're going to check is the positive X bound. So we're going to call this one positive X bounds for ball. Plug that in, and we're going to say positive X bounds for ball. And basically, every time we do this, we want to get the breakout ball. And what we want to do, we want to get its location. So what we're going to do is type in get world location. And then what we're going to do, we're going to break this vector. And then we're going to compare it with the value that we want. And obviously we're going to focus on the X value because that's the direction that we want. And we know from the actual player script what we want as the bounds. So the positive is 940, and then the negative is 350. So what we're going to do is we're going to compare this X value with 940. We're going to plug that in. And if it's greater, so basically if the input is greater than 940, what is it that we want to do? We basically want to set the velocity. We want to make the ball bounce the opposite direction, or at least simulate bouncing. So what we need to do, we need to get the ball movement, and we need to get its velocity. And then with the velocity, we want to also break this as a vector. And then basically the X direction, we want to multiply. So if you type in the star, you'll get a float by float multiplication. And we want to multiply this by -1. And then we want to go ahead and we're going to make another vector here. And then we also want to get the breakout ball variable again. So we're going to copy and paste this. And we're going to do set velocity. Actually, I'm sorry. It's actually going to be ball movement. We're going to do set velocity. And we're going to set the velocity whenever A is greater than B. And in this case, the ball's X value. If it's greater than 940, we're going to set the value of the velocity. And it's basically be the result of this vector here. So what we're doing, we're getting the ball's velocity when it hits that point. And when it hits that point, we're going to take its X velocity multiplied by -1, create a new vector, and make that vector the new velocity for the ball. So let's go ahead and see if that works. This would be very easy to test because our initial direction of the ball when we start playing is to the right. So we'll see if it bounces, and it does. But now it doesn't bounce all the way over there. So let's go ahead and we're actually going to set up the collision for that as well. So let's go ahead and set that up. We're going to go ahead and create, let me compile this real fast actually. We're going to create another custom event. And we're going to name this custom event negative X bounds for ball. And then I'm going to go over here. Oops. And then we're going to pull this pin for the second sequence, and we're going to type in -X. Got that going. And luckily, since we're dealing with the X direction, we can basically copy and paste this information, except delete the event so that now the initial event's the negative X bounce for ball. And all we have to update is the compare with. We want to make that, we're going to make that, I believe it's 330. And we're going to change the actual logic for the compare, because we don't want the ball to be less than 330 in the X position. If it is, it will keep moving left, which is not what we want. So now we should see it bounce on the left wall, which will be somewhere over here. Yeah, and there it goes. So now we have a problem where the ball can escape in the Z-axis. So we're going to have to set up that logic as well. So let's go over here. Let's create a new custom event. We're going to name this positive Z bounce for ball. Pull out the third pin here. Go type in positive Z bounce for ball. Now we got that going. Now this is where we need to change some of the logic. First thing we need to know is how high we want the ball to go. So somewhere around 586 was good. So that's going to be the max Z position that we want the ball to ever go before it bounces back. So we can actually copy and paste most of this logic, except there's going to be some things we need to change. Honestly, we're going to put this into the compare float, except we're not going to compare the X, we're going to compare the Z. So that's going to be our input. And the compare with is going to be the number 586. And then instead of multiplying the X velocity by -1 and creating that vector over here, we're actually going to multiply the Z by -1. Plug that into this make vector, and then plug these guys up. So let's see if that's working too. Okay, so we see there is an issue. Let's see. Okay, it's because of this value. We have to change the comparison to logic. Before we were saying, hey, you know, if you're below 586, you know, do this logic incorrectly. So we want to do it only when he's greater than 586. So that was a mess up there. So let's see if that's fixed it. Should have a ceiling, and it does. So now the only thing we have left to do is when the ball, if we miss the ball with the paddle, so say we don't catch it, it's just going to go on forever. And honestly, we don't want that. So we have to do one last piece of logic over here. It's going to be the fourth pin from this sequence. But let's go ahead and make a custom event. We're going to name this negative Z bounds for ball. Bring that down here for right now. We're going to pull this pin here, type in negative, and do negative Z bounce for ball. It's another all plugged into that. And then here, we're going to do basically different logic here, because what we want to have happen when the ball hits below the player, we don't want the ball to bounce at all. We want the ball to reset its position. And that's why we have this variable over here which says ball start position. So luckily we did that already, but the logic we need to do, it's similar to what we've been doing in terms of we need to get the location of the player and compare it. So we're going to copy that much. And if we go into our scene, the ball shouldn't go anywhere lower than here. And in the Z, it's about 16. So that's going to be our comparison number, so it's going to be 16. And we only want something to happen when the ball is less than 16. And what we want to have happen is we want to set the actor's position back to its start position. So what we need to do is we're going to type in set actor location. Plug that in here. Target will be itself. And then the actual location that we need to put in, let's get the ball start position and just plug that right in. So that's all we need to do for that. So let's test that out. And we see that it's working. But one thing, if you noticed, it doesn't go the same direction. It's going to start this way. And then basically it keeps the velocity that it ended up with when it went lower than that point. So we also need to set back its velocity. So what we're going to do is we're going to type in set. Actually, no, we need to get ball movement. We're going to type in set velocity. And what we're going to set this to is its default, the 200 in the X, and then the negative 150 by the Z. Something else we can do is also at this point, we get the ball movement. And then what we can do is get velocity. And then basically, we can set that. One moment, actually. Let me see. Actually, it might be just easier to have it have it set up right over here, where we just put in the values manually here, or we could just create a variable by scratch. Type in variable. It's going to be called initial ball speed. We're going to make this a vector. Tooltip, we're going to call this initial velocity. Let's actually change the name from initial ball speed to initial ball velocity, because velocity is speed and direction. And we're actually going to compile that just so we can get the options down here. And we're going to set this to 200, 0, and negative 150. And then instead of making these any kind of value, we'll just get this value and plug it in, and it'll do the same thing. So let's see if that makes the difference that we need it to. Oops. So we got that going. Now let's see if it, yeah, there we go. So we got that working too. So now we have all the directional bounds working, which is really good. But now what we're going to do, we're just going to make these functions just to clean things up a bit. So we're going to select each one by one, right click on it, collapse the function, and we're going to call this positive x bounds for ball. Or not, I guess we can't say that. So we'll call this positive x bounds. And we're going to replace this up here. And we're going to do this for every single one. So let's do, this is the negative bounds for ball. So we're going to select that, right click on them, collapse the function, call this negative x bounds. Replace that here. We're just going to keep doing this here. So this is the z, right click, collapse the function, name it positive z bounds. And then last but not least, we're going to do the z bounds. So select that, right click, collapse the function. We're going to call this negative z bounds. Then we're just going to plug that up. So now we have it set up so those long strings of blueprint nodes, now you can just double click and you'll see them. And everything still works the same. Oops. Let's go ahead and check it out, make sure. And it is working, which is awesome. And let's just make sure that it can reset its position too. Awesome. Okay, so we know that's working too. So one of the next things we're going to do here is we're going to change the ball color each time, basically each time a collision happens, except the negative z bound. We're going to reset its color at that point. So what we're just gonna start in blank space here. What we need to do is we gotta get ball color, and then what we need to do is set the vector parameter value, the parameter name. If we go back to our material, if you remember, this vector's name is ball space color. So that's the name we're going to reference here. So ball space color. And then we got to set a value here. So what we're going to do, you type in random floating range. So it'll create a random float between one number and another number, so minimum to maximum. We're going to set these values to 1 and 255 because that's the color range. We also need to right click, type in make color. And what we're going to do, we're going to copy and paste this 3 times. And then the return value is going to go into this value. So basically what's happening is we're making a random color and setting that color as that parameter for our ball color. So now we can just right click on this, collapse the, actually we don't need that as a node, let's redo that. We're going to make that a function. Right click, collapse the function, going to type in change ball color. So now what we can do, we can hit X on that, go into each of these, and then disconnect everything from there. Let's press Control V, get the change ball color, plug that in from the set right into the return. So now every time that the ball hits a positive X value, it's going to change color. So let's go see if that's working. And it is. So we know that's working, but we need to do that to every single collision we have involved. So let's do the negative X bound. We're going to delete off that, Control V, plug that up. And then we're going to go back to positive Z bounds. Disconnect those. Paste. Plug that up. Compile. And then we're going to do negative Z bounds, but we're going to do it a little differently. We're going to disconnect that. We're going to copy this still, but let's go into the change color. Actually, no, you can't do it this way because this will actually update for every single instance of it. So we need to do something special in this node because when the ball goes out of bounds, we want to reset its color to just white. So let's grab ball color. Let's type in set dynamic vector parameter. Put that in. Move that into position. Plug that up. But now we're going to change the value from black to white. And that should work. So let's see if this ball changes upon colliding with the walls. And it does, but it doesn't, as you can see, it didn't reset its color back to white. So let's see why. Oh, I know why. We didn't put anything for the parameter name. So let's call that ball color. So now this should work. So obviously let's save everything. So it's changing color every single time, and then let's see it go out of bounds, and it reset its color to white. So we got that working too. So far everything is working how exactly we want, but there's one last thing we're going to do in terms of the ball for this video. We want to make sure it recognizes when it collides with the player's paddle. So what we're going to do is we're going to right click, we're going to type in hit, and we got an event hit. Basically what we want to do here is other on the event. This basically tells you, hey, this is the other actor that hits this ball. So basically we want to check what class that is. So let's type in get class. It returns a class. And then what we want to do with that class, we want to compare, or we want to check what class it is overall. So let's type in the word class again, see if we can find this node. Yeah, equal class. And basically it's asking what class do you want to check if this is equal to. We want to check if this is the player. So let's type in player we should find breakout player. And then we want to do is branch out some information. So if this is true or false. So on the event hit, that's when we're going to branch out. And if it is the player, like if this is true, let's see if it'll actually print the string saying it did hit the player. So let's just make the string hit player. Let's compile, hit save, and we got the log right there. It said it hit the player. So we know that check is working. So what do we want to have happen when the ball hits the player? It could be whatever you want. In my instance, what I want to do is just make the speed of both the Z direction and the X direction go faster every time the ball hits the player. So that's what we're going to do. So let's get ball movement. Let's get its velocity. And we're going to break that vector. And then what we're going to do, we're going to multiply both the X. Actually, we'll do vector multiplied by float. So what we'll do is we'll just multiply every individual piece of the vector by, we'll do 1.15. And then what we're going to do at this point is we're going to set the velocity of the ball to this vector whenever that's true. And luckily, because of how our game is set up, the ball has 0 velocity or speed going in the Y direction. So if we multiply 0 by 1.15, we're still going to get 0, so we won't see a change in the Y velocity, but we will see a change in the Z and the X. So let's go ahead and see if this works. It's kind of hard to tell just because it's a small number, so let's just make this 5 for troubleshooting purposes. Save everything. And it is. So we can see that's working. So we're going to make this just 1.15 because we obviously don't want it to speed up that quickly. But let's also put it in a self-check. So let's break this vector. We're going to compare float. We're going to compare this with the absolute value of that float. Actually, yeah, this is what we're going to do. We're going to get the absolute value of x, meaning even if it's positive or negative, we're going to get the absolute value. We're going to compare that with how fast we would want this ball going overall. So let's say we don't want it to get past 500. What we're going to do is compare this float, and if for any reason if the x value, the absolute value, gets any greater than 500, we want to set a new velocity. And the velocity is actually going to be different than what it's going to be over here. So we're going to disconnect that. What we're going to do is we're going to make a vector with that value here. And we're going to do the same thing for the Z value. Actually, no. Let's say we don't want them both to be equal to 500 at a time. We should be able to do both. No, never mind. So let's just put it in again. So let's create a sequence up here. One up here, one down here. But we want to do the absolute value again. We'll put that into Z. Put that into there and set that as our vector. So we don't want the speed of both the Z and the X direction to ever get above 500. So let's compile, make sure there's no errors. Let's multiply this by 5 again. And let's see if it gets faster than 500 velocity. Whoa. Let's multiply it by 2. So it doesn't get too crazy. So far, it's going pretty good. Let's try multiplying by 3 to see if it gets faster. Whoops. Oh, okay, so I think something's going on with the actual vector here. So we're actually going to do this. We're going to plug directly into the Z and the X from the original vector. We're not going to do the absolute value. That might be what's causing it to hiccup like that. Let's try again. Oh, hello. But we'll also do, let's see. We'll leave that alone for right now. We'll just make it 1.15. Because right now everything's working so far, just in terms of how we have everything set up. We've got the color changing. The ball does speed up slowly at this point. So that's really it for this part of the tutorial. We got the ball working pretty well. It recognizes when it gets hit by the player. It recognizes when it's leaving the bounds. So we know that's all working. So I think this is a good place to stop. So I definitely appreciate you guys watching this tutorial. The next one we're going to do, we'll start setting up the player bricks. So at the top of the screen, we'll see if they can recognize hit events. We'll make them have point values. We'll do all that fun stuff. So again, thank you for watching. If you haven't subscribed yet, please do so. I definitely appreciate it. In the comments, let me know what you thought. If anything confused you, if you have any questions or suggestions for other videos, and definitely leave a like and share this if you liked it too. Because the more the merrier. So let's do it. I'll see you guys next time. I want to thank you one more time for watching, but see ya.